Hello! Great day everyone! So this video is a course requirement in Math Analysis for Teachers at St. Paul University, Philippines Graduate School for the summer term 2020. At shout out po dyan sa professor namin, si Dr. Jess Pizarro. Hello sir! Okay, so our subject for today is calculus, and the topic that was given to me is the differentiation of trigonometric functions or the derivatives of trigonometric functions. And I am Mark Angelo Binarao, your presenter for today. So since there are different formulas in trigonometric functions, first I will present to you the different formulas. Let's start with the first formula, which is the derivative of sine u with respect to x is cosine u du dx. And the derivative of cosine u with respect to x is equal to negative sine u du dx. And the third formula is the derivative of tan u with respect to x is equal to secant squared du dx. And the fourth formula is the derivative of cotangent u is equal to negative cosecant squared du dx. And the fifth formula is the derivative of secant u is equal to secant u times tan u du dx. And the last formula is the derivative of cosecant u with respect to x is equal to cosecant u times cotangent u du dx. So these are the 6 formulas that we are going to use for the next problem. And as you can see on the different formulas, in order for us to master it easily, if the derivative starts with c, automatically it is equal to the negative. It is equal to negative sine, negative cosecant squared, or negative cosecant u, cotangent u. So there are different ways on how to master this. But the best way is to practice and practice and practice solving. So let's start to solve problem number 1. So our first function is equal to, the f of x is equal to sine 2x. In order for us to solve the function, this function, we need the formula. The derivative of sine is cosine u du dx. We have to identify first our u. And based on this sine 2x, our u is 2x. So, therefore, if our u is equal to 2x, and then the derivative of u is equal to 2. With respect, that is, the derivative of u with respect to x is equal to 2. And therefore, we are now ready to substitute the values using the formula cosine u du dx is cosine u, which is equal to 2x, so that is cosine 2x, times the derivative of u, which is equal to 2, so that's why we have 2 here, and that is already our acceptable answer, but we have to rewrite it in the standard form. Therefore, the f prime of x now is equal to 2 cosine 2x. So as simple as that. Next, let's proceed to the next example. Example number 2. F of x is equal to cosine quantity 3x squared minus 1. So we will do the same thing. We have to identify our u, and in order for us to solve the derivative of a cosine, we need the formula, the derivative of cosine is equal to negative sine u du dx. And our u for this equation is 3x squared minus 1. So therefore, we have to get the derivative of 3x squared minus 1, which is equal to 2 times 3 is 6x, and the derivative of constant is 0. That is why the derivative of u now is equal to 6x. So now we are ready to substitute the values using the formula negative sine u du dx. So, negative sine u du dx, and our u here is 3x squared minus 1. So f prime of x now is equal to negative sine, our u is 3x squared minus 1, so that's 3x squared minus 1, times the derivative of u, which is equal to 6x. So that is sine quantity 2x squared minus 1 times 6x. So therefore, we have to rewrite this in the standard form. That is why our final answer is negative 6x sine quantity 3x squared minus 1. So let's proceed to the next problem. Example number 3. Example number 3, f of x is equal to cosecant e raised to 3x. So our formula that we are going to use here is negative cosecant u times cotangent u du dx. So first thing is you also have to identify our u, which is equal to e raised to 3x. And applying now the rules, the derivative of e raised to 3x is equal to e raised to 3x times 3, which is equal to 3e raised to 3x. That is why our f prime of x now is equal to negative cosecant u cotangent u du dx. Therefore, we are now ready to substitute the values of u and the derivative of u. So that is why f prime of x now is equal to negative cosecant. Our u is e raised to 3x. That's why this is e raised to 3x times cotangent u, which is e raised to 3x again, times the derivative of u is equal to 3e raised to 3x. That is why we need to rewrite this in a standard form, and our final answer is negative 3e raised to 3x cosecant quantity e raised to 3x and cotangent e raised to 3x. So let's proceed now to example number 4. Example number 4 is f of x is equal to tan quantity x squared minus 1. So using the formula secant squared u du dx, again we have to identify the value of our u, which is x squared minus 1. So that is our u, x squared minus 1, and the derivative of u with respect to x, that is 2x. Since x squared is 2 times x now, and the derivative of a constant is 0, that is why the derivative of x squared minus 1 now is 2x. So we are now ready to substitute the value using the formula secant squared u du over dx. That's why f prime of x now is equal to secant squared times the quantity u, which is x squared minus 1, times the derivative of u, which is equal to 2x. That's why f prime of x now is equal to secant squared quantity x squared minus 1 times 2x. And now we are going to rewrite it in standard form. Therefore, f prime of x now is equal to 2x secant squared quantity x squared minus 1. So these are very easy examples. Now let's proceed to a little bit challenging by applying the different formulas. And that is for example number 5. Since our example number 5 is f of x is equal to 1 plus cosine x all over sine 5x squared. So as you can see, we have to apply here the quotient rule, and applying the quotient rule at the same time also we need to apply the derivative of the trigonometric functions. So let's review the formulas for quotient rule, which is low d high minus high d low all over low squared. So low is the denominator and high is the numerator. So that is how we do it in order for us to master the rule easily. And now we need to apply this low d high minus high d low over low squared. So our law is sine 5x squared, and then the derivative of our numerator 1 plus cosine x minus our numerator 1 plus cosine x times the derivative of our law, which is sine 5x squared, all over our law or the denominator is sine 5x squared raised to 2. So let's solve first the derivative of 1 plus cosine x. So 1 plus cosine x is just simply negative sine x. So we also apply here the trigonometric functions now. And for the derivative of sine 5x squared, it's here. The derivative of sine 5x squared is equal to 10x. So that is 2 times 5x is 10x times the cosine 5x squared. So that is now the derivative of sine 5x squared with respect to x. So we are now ready to solve this. So f prime of x now is equal to sine 5x squared. We simplified this a while ago by solving the derivative of 1 plus cosine x, which is we get the value negative sine x minus 1 plus cosine x, and the derivative of sine 5x squared is 10x cosine 5x squared all over sine 5x squared raised to 2. So as you can see in this example, we are applying the derivatives of trigonometric functions and at the same time the quotient rule. So as we go on through the different rules in derivatives, we are applying also the different formulas that we've learned before. That's why we need to practice in order for us to master the different rules in derivatives. And that is our last example. So I hope you've learned something today. Thank you very much, guys. And please don't forget to subscribe in my channel. Thank you po.
I'm not gonna make it alive. La, 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 la.